Okay, cool. Looks like I'm live. Notes. There is a little bit of a delay, but that's not a problem. So essentially, I'm taking a course on assembly language. I'm pretty familiar with it already, but I'm kind of just starting from the very beginning because I really want to shore up my knowledge. But yeah, that's pretty cool. I really do enjoy doing it. It's definitely a little bit more complicated. You really need to understand the hardware a lot better. Alright, so essentially I'm just going to start off with a blank file, and then this defines where every part of the program is going to be. If you are familiar with some of the hardware and how it works, then I don't need to really explain this to you. I'm not actually going to explain some of this stuff because honestly it's just too much to get into if I really want to just practice. But I'll try to explain as I go a little bit. Let me minimize that. There we go. I would like to be able to interact with people on my stream because I don't really think I have the ability to interact with people from here. No, I don't think I do. Okay, cool. Now I can interact. Awesome. We got vectors. So we got code, 0 page. So I'm kind of working backwards, but just do that. Reset. Need to put this into code, not into cars. There we go. And then for the header is weird. The first 16 bytes, I don't remember, but I do remember the first 3 bytes or so need to spell out NES, and then it's And then it is a new line space. I'm just gonna look it up so I don't need to put it myself because I don't remember. Okay, this is stupid. Let's use one of my other files. That's right. I don't think I need this org, but I can state it right there. Yeah, so this is NES, new line. So this byte determines number of 16-byte program ROM we have equals 2, so total 32 bytes. And then this is number of 8-byte CHR-ROM. I think the CHR is only 8 bytes total. Because the CHR-ROM contains all the pattern tables. I think that's good. I can check later. And then all these other bytes, they mean a variety of different things. I'm not going to get into it at the moment, though. And let's have a make file, which I will also just cheat and copy this because I don't need to. Oh, I already have this here. This can build practice up to movement 2, make 22. I said code. I meant to say segment. Segment. Cool. Okay, we're not going to see anything, but that's fine. Oh, I see my stream. I'm actually blocking some of the content. Can I move that? Yeah. A bit much smaller. There we go. Okay, so that's the basics of it. Alright, so the first thing that I want to do is I want to just set up my NES. So I want to, clear the decimal system, to clear the decimal mode. And also SEI, which is, I don't even remember. SEI, where are you? Where are your opcodes? Yes, it's used to prevent the maskable interrupts. Okay, so while this is booting up, prevent maskable interrupts. RQ. And then we want to load the stack at FF, load stack pointer at FF, top of the stack. We transfer it to the stack. Transfer FF to the stack. And what else do we want to do? Let me bring up my notes. There is something else we want to disable, if I'm remembering correctly. I think it's like the 44014 register. Right now. It's hard to remember all these like little things. This is my other practice file that I did. Reset. Disable. Yes. See, this is what it is. So we want to control the masking. Okay. So increment X causing a roll off from FF to O. Okay. Then we disable the NMI. We disable the rendering. We disable all that stuff. Then I guess after that, we need to wait for the v blank, the first v blank to occur. So why don't we do bit, and I'm going to actually here define some constants. So I actually, from when I copy pasted that, so PPC control is located at 2000, PPC mask, I believe, is 2001. PPU status is at 2002. PPU OAM is at 2003. I'm gonna check before I finish this, but PPU OAM status, this is probably wrong, is equal to 2004. And then I do remember PPU address is at 2006. PPU data is at 2007. And then PPU, I don't remember. Check our notes. PPUC status OAM. Yeah, OAM address. Data. Oh yeah, the PPU scroll. RAM. X equal to 0. A is equal to 0. So now we need to clear the RAM. That's like the next thing that we need to do. The RAM pretty much goes up until this address right here, 800. So what I'm going to do, and I think actually the smart way to do this is actually load this up with FF. And what I'll do first, after that, I will increment X. I'll compare X to 0. And then, so if the accumulator is greater, or no, branch if equals, that's what I should do. Branch if not equals. So if it doesn't equal 0, wait a second. No, wait a second. Maybe I'll start this off at 0. Because then it'll increment, it'll get up to FF. And then when it finally equals FF, branch if not equal to the last loop, and then I will also then store it in, there we go, like that. So that's clear RAM, and then we need to wait for second v blank. Bridge plus wait for second v blank. Cool. And then what do we do now? Well, the first thing maybe we want to do is maybe we want to load palette data. So why don't I do reset? Oh no, I already reset, excuse me. Main. And I'm going to just copy and paste some palette data just because it's much quicker. Enormous amount of palette and attribute data. And we'll just start off with this though. Keep it simple. Palette data. Okay, so load palette data. Okay. Now how are we going to do this? Well, let's just split this into two because I think I want to look at this. So the place, so the PPU is going to insert inside the PPU. It's going to read colors at PPU palette data is equal to 3F00. That's where it starts with the palette data. So let's just do. So we need to load the high byte of PPU palette data. Store that bitch in the PPU address. Get high byte. Yeah, load the high byte first, which is 3F. Then load the low byte. Get low byte. Again, I should say store the low byte second, And now that we have that, I pretty much can just loop through palette, and say, also I'll start with this load X, and then I can say load palette data at X, so it gets 22, and then I'm going to store it. I'm going to store that in PPU. When I store PPU data, do I need to strobe the address? I don't think so. I think the address automatically increments when I store PPU data. I can compare to X to be 32. Because 4, 8, 12, 16 times 32. And it starts at 0, so eventually this will be it. So branch, if not equals, back to loop through palette. And I think that should properly load the palette data. Let's see. Oh, wait, I didn't save it. Let me try this again. Make run. Let's see the PPU viewer. Okay. Okay, so apparently it's not liking something. Oh, wait for a second, v blank. That makes sense. You know why? Because I'm supposed to be bidding it. Okay, I forgot. View status. That's what I'm supposed to do. Now, is this done twice, though? No, it's not done twice. Okay. And I'm not incrementing X, so of course that would do that. Okay. You know what, YouTube? If no one's gonna be watching, I probably should not even be wasting my time streaming on this. Is anyone even watching? Let's see. Nope. Nope. Fucking finish this. Yeah. Maybe I'll just try Twitch then. How do I get out of this now? Oh, okay, stop streaming.